When graphing a piecewise function, I like to think of each piece separately first and then bring it together. So for the first graph, I want to graph the complete equation y equals negative 2x plus 3. This is a line. I know we have a y-intercept of positive 3 and a slope of negative 2. So I'm going to continue with a couple of points. From this y-intercept, I'm going to go down 2, right 1. I'm going to go down 2 again, right 1. Okay, so I have the point 0, 3, 1, 1, 2, negative 1. I'm going to go one more point to the right, and this will be down 2 over 1, which will land at 3, negative 3. The reason why I wanted to continue beyond the value of 2 is because if you look at the equation, we're cutting off here at an x value less than 2, so I want to see what's going on around that x value. Now let's look at the second equation. We have y equals x minus 3. I'm going to graph this in its entirety. I know this graph has a y-intercept of negative 3, a slope of 1, so we're going to go up 1, right 1, up 1, right 1, up 1, right 1, and I am going to continue this line. I'm going to put one more point on this line. So here we have 4, 1, 3, 0, 2, negative 1. Once you have these two graphs, which are part of your piecewise, we can now select the portions that we need for each one. So if I look at negative 2x plus 3, I want to look like this graph for any x value that's less than 2. So I'm going to highlight, here's my x-axis. What you see highlighted in yellow, these are all of the x values less than 2. So that means I want this portion of the graph that's less than the 2. I put an open circle at 2, negative 1, and then I want the entire graph to the left of that. So that's everything that you see in red here. So that portion is going over to my final picture. I have the point 2, negative 1 with an open circle because of the less than. I can have any x value as close to that x value of 2 as I want. I just can't hit it. And then I'm going to transfer the other points that we graphed. We have 1, 1 and 0, 3. So this is the portion of that equation that we want. Now I'm going to go to x minus 3. I'm going to look like this function for x values greater than or equal to 2. So I'm going to highlight along my x-axis. This is where x is greater than or equal to 2. Because of the equal sign, at the x value of 2, we are going to have a closed circle. And then I want any x value that's larger than that. So that means I'm going to choose the portion of my graph that goes to the right. And now I transfer that onto my final picture. I have the point 2, negative 1. So it actually fills in this hole we had before, 2, negative 1. And then I transfer the rest of the information. We had the point 3, 0 and the point 4, 1. And now taking these two pieces together, that's the graph of the piecewise. Now if we look at a function that's a little more involved, again the first one that I want to graph is y equals negative x squared plus 10. This is my parent function x squared. I know my parent function starts at the origin, and I have the points 1, 1, negative 1, 1. So the transformations that this parabola is going to reflect over the x-axis, so it's going to go upside down and then move up 10 spots. So my vertex is up here at 10, and I know my parabola is upside down. If I look at my equation, I see that I'm cutting off at -4 and 4. So a shortcut here that we could use is that if I take the -4 and plug it into the -x² plus 10, that's going to give me a point on my graph here that I will need for later. So this equals -6. So that means I have the point -4, -6. If I plug in a +4, again, because that's an endpoint that I have, I get a -6 again. So I have 4, -6. Again, this was -4, -6. So this piece is a parabola. Then my other equation, y equals 6 minus 3x. I know I'm going to cut off, again, around this 4. So that could help me with my points. I know I have a y-intercept at 6. 1, 2, 3, 6. Okay, I have a slope of -3. So we're going down 3, 1, 2, 3, right 1. Down 3, 1, 2, 3, right 1. The reason why I keep going is because I know I have to have a value at 4. I could get this by plugging in, or I can continue with my slope. So important points that I'm going to need, I have the point 4, -6. I also have the point 5, -9. So here is the graph of that second equation. Here's where we go in and select the pieces that we need. Back to the first graph, I want to look like -x² plus 10 for x values greater than or equal to -4 and less than 4. So if I go to my points at -4, -6, I am going to have a closed circle. At 4, -6, I will have a open circle because I don't have the equal sign in that interval, and I want points for any x value between -4 and 4. So that means that portion of my graph is going to go in my final picture. So I have -4, -6. I have the point 0, 10. And then I have the open circle at 4, -6. I'm transferring the red that we selected here. Now if I go to graph number 2, I want to look like this function for any x value that's greater than or equal to 4. So at an x value of 4, I have a y value of -6. So at the point 4, -6, I will have a closed circle because of the equal sign. And I want any point with an x value that's greater than 4. So that means I want the portion of my graph that's to the right of that point. I will now take this information, transfer it over to my final graph. 4, -6 fills in this open circle from before. And then I also have the point 5, -9. This is a straight line, so when you draw it, you want to make sure you include that.